Let g be a function defined for all real numbers. Also let g prime, the derivative of g, be defined as g prime of x is equal to x squared over x minus 2 to the third power. On which intervals is g increasing? Well, at first you might say, well, they don't even give us g. How do we figure out when g is increasing? Well, the answer is all we need is g prime, which they do give us. And saying on which intervals is g increasing, that's equivalent to saying on which intervals is the first derivative with respect to x, on which intervals is that going to be greater than 0. If your rate of change with respect to x is greater than 0, if it's positive, then your function itself is going to be increasing. And so there's a couple of ways that we could approach this. You might just want to inspect kind of the structure of this expression and think about, well, when is that going to be greater than 0? Or we could do it a little bit more methodically. We could say, well, let's look at the critical points or the critical values for g. So critical points for g. And just to remind ourselves what critical points are, that is when g prime of x is equal to 0 or g prime of x is undefined. And we have videos on critical points or critical values. And why those are relevant is those are the possible places where the sign could change. The sign of g prime could change. So when is g prime of x equal to 0? Well, the way to get g prime of x equal to 0 is getting the numerator equal to 0, and that's only going to happen if x squared is equal to 0 or if x is equal to 0. So that's the only place where g prime of x is equal to 0. And where is g prime of x undefined? Well, it's going to be undefined if the denominator becomes undefined. The denominator becomes undefined if the denominator is 0. And so that's going to happen if x minus 2 is equal to 0. X minus 2 is equal to 0, or x is equal to 2. So we have two critical points or critical values here. And what I'm going to do is I'm going to graph them. Let's put them on a number line. And let's just think about what g prime is doing in the intervals between the critical points. So let's start at 0, 1, 2, 3, and then let's go to -1. And we have a critical point at, let me do that in magenta. We have a critical point at x equals 0, right over there. And we have a critical point at x equals 2, right over there. And so let's think about what g prime is doing in the intervals between the critical values, or on either side of the critical values. So let's first think about this interval. Let me do it in this purple color. Let's think about the interval between negative infinity and 0. So if we think about this interval, so negative infinity and 0, that open interval. Well, if we look at g prime, the numerator is still going to be positive. You take any negative value, you square it, you're going to get a positive value. So this is going to be positive. Now what about the denominator? You take a negative number, you subtract 2 from it, you're still going to get a negative number, and then you take it to the third power. Well, a negative number to the third power is going to be a negative number. So that right over there is going to be negative. So you're going to have a positive divided by a negative. So g prime is going to be negative. So let me write that down. So on this interval, I'll write it like this: g prime of x is less than 0. Or if we cared, if we wanted to know when it's decreasing, we would know it's definitely decreasing over that interval. Now let's take the interval between 0 and 2, right over here. So this is the interval from 0 to 2, the open interval. So what's going to go on with g prime of x here? Well, once again, x squared, anything greater than 0, and it says we're not including 0 in this interval, well, this is for sure going to be positive. And so let's see, if we have x minus 2, where x is greater than 0 but less than 2. So if x, we could just say, for example, if x was 1, 1 minus 2 is -1. We're still going to get negative values in this denominator right over here. So since we're still going to get negative values in this denominator, the denominator is still going to be, take a negative value to the third power, well, you're going to still get a negative value. So this is going to be negative. So you're still going to have g prime as less than 0. So let me write that down. So you still have g prime of x is less than 0. And then let's take the interval above. Let's take the interval from 2 to infinity. 2 to infinity. Well, the numerator is positive. It's always going to be positive for any x not being equal to 0. And this denominator, you're taking values greater than 2, subtracting 2 from it, which is still going to give you a positive value. You take the third power, it's all going to be positive. It is all going to be positive. So this is the interval where g prime of x is greater than 0. So on which intervals is g increasing? Well, that's where g prime of x is greater than 0. So it's going to be from 2 to infinity. Or we could just write it like this. We could write x is greater than 2. Either way, if for either of these, g prime of x is greater than 0, and your function g is going to be increasing.